Hi, welcome to the 4.1 Classifying Quadrilaterals video. Today we're going to be going through about 8 examples of facts of a given quadrilateral, and we are going to classify that quadrilateral given the best name possible with the facts that are given. Okay? So, when drawing or sketching a polygon, consecutive vertices in the name of the polygon must be consecutive vertices in the actual polygon. So, for instance, if we have A, B, C, D, if I wanted to draw a quadrilateral, and most of the quadrilaterals I draw today, I'm going to draw and make them look like rectangles. That doesn't mean that they are, but if I'm going to go ahead and label this, I need to be consecutive. A goes to B, goes to C, goes to D. Now I could have gone the reverse. I could have gone A, B, C, D. That would also work. Now this next one, A, C, B, D, okay, I need to make sure that they all fit here the way the name is here. A goes to C, goes to B, goes to D. Now, we're not doing this to try and confuse you. Most of these are going to be alphabetical in how we name them, but occasionally things do get mixed up, and you do use points that aren't alphabetical like this, so you need to be aware of how to label them correctly. Okay, let's jump right into the different quadrilaterals we're going to be working with. So here we have quadrilateral ABCD. Now again, I'm going to draw this. It's going to look like a rectangle, but I'm only doing it so I have something to label. Okay, so I have something to label my congruent parts on, and we can then adjust it accordingly. All right, so A, B, C, D. So I'm going to go ahead and label my vertices A, B, C, and D. Okay. We're told that AB is congruent to BC, which is congruent to CD, which is congruent to DA. Looks like all four sides are congruent. Okay, so now this is where, once we've labeled all the facts, we can narrow our list down to only the quadrilaterals that fit this description. Okay, now I can look at this and I know that, let's see, what quadrilaterals have all four sides congruent? Well, I know squares do. So that's a possibility. And I also know that, let's see, a rhombus also has all four sides congruent. Okay? I think those are the only two of our quadrilaterals where this is going to fit. Now the question is, what's the best name? Now, the problem we have here is that they both fit, but if I'm going to say what's the best name, I know for a fact that any quadrilateral I draw that has four sides congruent is going to be a rhombus. Okay? I don't know that every one is going to be a square. Well, a square is a rhombus, so that it kind of fits inside this circle. But I don't know that it's going to be a square. Even if I draw it to look like a square, I'm not given the facts to prove that it's a square. So the best answer for this one is going to be rhombus. Okay? It's because we don't have enough information to guarantee that we're drawing a square. All right? So rhombus is the correct answer. And before I move on, I should have said this earlier. What I recommend you guys do, like when I go to this next slide, pause your video and try and do this on your own before I go through the explanation. Okay? Try and draw the quadrilateral, figure out what you think the best name is, and then as I go through the answers, you can either verify it or figure out where you went wrong. Okay? All right. So again, I'm going to draw another one. Again, making it look like a rectangle, even though this probably isn't a rectangle. Label my sides here. A, B are my vertices. A, B, C, and D. Okay. A, B is parallel to CD. All right. A, B is parallel to CD. So basically the top and the bottom are parallel. BC is congruent to DA. So these sides are congruent. Now, let's take a look at what fits this description. Now, all parallelograms do fit this description, okay? Because I know in all parallelograms, opposite sides are parallel and opposite sides are congruent. So that would be a parallelogram, rhombus, rectangle, square. Um, let's see, does it fit trapezoid or kite? It doesn't fit kite, okay? It does not fit the kite, but it does fit trapezoids because we have parallel sides here, and then BC and AD would be legs. If it were a trapezoid, it'd be a specific trapezoid. It'd be an isosceles trapezoid. And in this case, our best name, because I know it fits all parallelograms, it does fit trapezoids. Okay. In this case, my best name for this one, because the problem with parallelograms in this diagram, I don't know if these sides are parallel or not. I know they're congruent, but I don't know if they're parallel. So my best name in this case is actually going to be a trapezoid, but it's going to be an even more descriptive than trapezoid. It's going to be an isosceles trapezoid. Okay? Because isosceles trapezoids are the ones that have one set of parallel sides and their legs are congruent. Okay? So if I were to draw this more precisely, okay, I would probably draw it where I had parallel sides and congruent lengths. Okay, my freehand isn't as good as my rectangle over here, but isosceles trapezoid would be the best answer for this one right here. Okay, all right, let's move on to the next one. Okay, I've already got my rectangle drawn here. Again, pause it, give it a try. Labeling my sides here, A, B, C, D. Marking my congruent and parallel parts. AB is parallel to CD. BC is parallel to DA. Well, right away I know it's going to be in the parallelogram group. AC is congruent to BD. All right, I'm going to use the line tool here to make sure I do this right. AC is congruent to BD. So these two diagonals are congruent. Well, let's think about this. Let's think about what parallelograms have congruent diagonals. Okay? And there are two of them. All right? There are two. We have rectangles and squares. Now, isosceles trapezoids also have congruent diagonals, but isosceles trapezoids don't have two sets of parallel sides. So that doesn't fit. These are the only two that fit this description. Now the question is, which one's the best name? And just like we did a couple slides ago, the best name in this case is actually the least descriptive one, the rectangles, because we don't have another fact that would guarantee to make this a square. If we want this to be a square, we need another fact. We need some fact that's either going to, like maybe diagonals are perpendicular, because that would fit then. If we had congruent diagonals and they're perpendicular, that would make it a square. If we knew that two sides were congruent, okay, not just opposite, but consecutive sides were congruent, that would be enough to say it's a square. But with the given information, these three facts, the only thing we can guarantee is that it's a rectangle. Okay? So that would be our best name for this one. Number 6, or slide number 6. Let's see, let's put my rectangle out here. Label our vertices A, B, C, D. A, B, C, D. Let's mark our things we know here. AB is congruent to CD. BC is congruent to DA. And angle ABC, ABC is a 90-degree angle. All right. Now, we can use one of our theorems in here as well. Opposite sides are congruent. Both two pairs of opposite sides congruent. That is a parallelogram theorem. So this is going to be some type of parallelogram. Okay. Now, what types of parallelograms have right angles? Okay. Well, we got our rectangles and we got our squares. Okay. And just like before, the best answer here is going to be rectangles again. And the reason is because I can't guarantee that AB and BC are the same length. Again, if we had AB is congruent to CD, which is congruent to BC, which is congruent to DA, showed all four of them congruent to one another, yeah, this would definitely be a square. Okay. In fact, if we went back to our first example, if we had put angle ABC as 90 degrees, we would have gone with square in this case instead of rhombus. Okay. But in this example, we're given that the sides opposite are congruent, which makes it a parallelogram. All right. And that 90-degree angle, that's enough for us to figure out if we know it's a parallelogram. Well, we know consecutive angles are supplementary, so that has to be 90. Opposite angles are congruent, that has to be 90. Opposite angles are congruent, that has to be 90. Well, we just drew a rectangle, okay? And it fits because these two opposite sides are congruent and these two are congruent. But we don't know they're congruent to one another. So that's why we got to stay with rectangle. Okay, here's another one. Looks like we got a couple sets of parallel sides. Looks like we got another parallelogram. Rectangle. AB is parallel to CD. Whoop, gotta leave my sides, or my vertices. AB is parallel to CD. BC is parallel to DA. And AC is perpendicular to BD. AC is perpendicular to BD. All right, so let's see if I can pick one that's not as thick. So while I didn't draw it to where they are, we're told that these things are wrong tool. We're told that these are perpendicular, okay, which means they'd all be perpendicular. Well, the opposite sides being parallel, two pairs of them, tells me it's a parallelogram. So what parallelograms have diagonals that are perpendicular? Well, guess what? We're back to our square and rhombus again. And in this case, just like before, we got to go with the lesser one. We don't have enough information to say it's a square. Okay? We're only told that it's a parallelogram with diagonals that are perpendicular. We don't have enough information to say that there's a right angle out here or that sides are congruent. Because we don't have that information, we can only say that it's a rhombus. And again, a square is a rhombus, so this could be a square, but we don't know that because we don't have enough information to verify it. So rhombus was the best answer. All right. Let's draw our rectangle figure here. A, B, C, D. AB is congruent to BC. AB is congruent to BC. CD is congruent to DA. Now, we are not given the fact that these single hashes and double hashes are the same. So all we know are that these two are the same and these two are the same. Okay? Well, we call these consecutive sides. Well, these facts are actually, these are the base for the definition of one of our quadrilaterals. Two pairs of consecutive sides congruent. It's the last one we did. This is a kite. Okay, this is a kite. Because we know that if we were to draw it a little bit more like a kite, then these two lengths, A, B, and BC, would look to be the same length. And then the others would, AD and CD, would also look to be the same length. All right, but this is a kite based on these two facts. A parallelogram with a right angle and diagonals that are perpendicular. Okay, so this is written in sentence form, but it's the same idea. They're two facts. A parallelogram, so we know it's in the parallelogram group right away, which is good. That narrows it down. With a right angle, so we know that there's a right angle, and diagonals that are perpendicular. All right, so, oh my goodness. Let's just get on this still. All right, diagonals are perpendicular. So, again, we figured out before if we had a parallelogram with perpendicular diagonals, it was going to be a rhombus or a square. But in this case, we're given an additional fact. We have a right angle. Okay, we know we have at least one right angle in the parallelogram. Well, we figured out before, if you know one's a right angle in a parallelogram, you can figure out that the other three are as well. Well, the only figure that's going to fit both of these things, the right angle and the perpendicular diagonals, is a square. Okay? Again, a square is a rhombus, so this does fit a rhombus as well. But we know that we've got right angles for our interior angles now, which makes it for sure to be a square. So that's why we want to use square, okay, as the best name for this one. Last one. A quadrilateral with one pair of opposite sides parallel and the non-parallel sides are not congruent. All right, so one pair of opposite sides parallel. So I'm going to make the top and the bottom parallel. And the non-parallel sides are not congruent. All right, I know it's not a parallelogram, okay? It's not a parallelogram. So if it's not a parallelogram, it's either a kite or a trapezoid. Well, we just kind of figured out it's not a kite because kites don't have any parallel sides. So the only question is trapezoid the best name or isosceles trapezoid or right trapezoid? We don't know anything about angles, so it can't be right trapezoid. And if it were isosceles, these two opposite sides will be congruent. So plain Jane trapezoid is all we're going with.